When I'm considering performance and trying to fix performance problems, I normally consider them from three different perspectives. The first would generally be hardware, infrastructure, networks, devices. The second perspective would generally be data readiness, and the third perspective would be appropriateness of processes, which would generally include runtimes. Looking at the first element, applications like FileMaker are particularly vulnerable to deterioration in performance when there's a high latency situation. Browsers, when communicating with outside services, are generally sending a very small number of messages to or receiving a very small number of messages back from a server, or the messages they do send are not rich. They're very light. They include very small payloads for various reasons. So sometimes you can have a very high latency situation, and for this reason alone, it won't really be very noticeable for a user. You can also have, for example, applications running on mobile devices which can hide latency issues from users by running processes in the background that the user doesn't really see the application is dependent on. Generally speaking, in FileMaker applications, enterprise applications, custom applications, client-rich heavy applications, data-heavy applications, we have issues of a large amount of data being transferred back and forth and not having as many resources available for optimization. If you're developing an iOS app, for example, for millions of people, you can afford to invest more resources in optimization that hides latency issues from the user. When you're in a platform like FileMaker, you actually have less control over these things. And in any case, even if and where you can have control, you can't necessarily invest as many resources for custom applications. Even if you're developing for a large organization with healthy budgets, you still can't invest the same amount, especially because of the broad number of features you may have to accommodate. So this is definitely an issue. And from a hardware infrastructure perspective, the quality of connections, type of connections, the hardware that's running can make a very big difference. But these latency issues are also dependent on and have an impact on the other two categories of performance that I mentioned. So I'll move on to that second category now, which is data readiness. It's normally a very cheap thing from a investment perspective in terms of developer time, and also from a data storage perspective, and also from a processing perspective. It's generally very cheap to prepare data in advance. So if you have data going into a system, applying some quality control as it goes into the system or as it's queued up to go into a system so that it's prepared in certain formats and cleaned up before later usage can make a very big difference. Similarly, if you have data that's meant to be a single point of truth, but it's useful to have that data in various formats, it can be very sensible to create stores of all of those various formats for processes to run much more efficiently later on, because you can run processes more simply on data that's already been prepared for you. That can make a very big difference. And then from a processing appropriateness point of view, it's possible, for example, to have processes that conflict with each other, that overrun each other, and that can sometimes be easy to avoid and sensible to avoid. It's also possible to have very inefficient processes written, or processes written in the wrong order. So, for example, there may be processes which are sorting data when before cycling through that data, say records one by one. And sometimes sorting can be very resource intensive, and it's just not necessary. So generally, whether it's a user process or a preparation process, an update process, optimizing processes can make a very large difference. So definitely try to consider all of these three factors at the very least when you have performance issues or when a system is at its inception.